Hey, thank you, everyone. Good evening. Okay. So, like Doug said, my name is Matthew Foster with the National Weather Service here in Honolulu. I've been here about 10 years total, or in Honolulu for 10 years, and then 12 years with the National Weather Service in total. So I'm going to be talking tonight about the April 2018 floods. Kind of more from a meteorological standpoint, and we'll get into some of the hydrology as well. So here's the event summary. So what started this whole event was we had this upper low that was tapped in, upper low that was off to our west of the state. And we had some enhanced moisture that was moving in with the trade wind. So we kind of had two things colliding. We had the instability that was provided by the upper low to the west, running into this area of enhanced moisture that was blowing in with the trade winds from the east. So the result was we had localized torrential rainfall over the East Oahu communities on the evening of April 13th. Now, most of you guys remember probably April 13th, the evening time, which is about 6 to 9 p.m. But this entire event actually went all the way to April 15th. It went through the entire weekend. And you guys probably saw the images of Kauai, the Hanalei Bridge getting washed out, and that the Hanalei being completely isolated for about a 2-week period there. So they suffered quite a bit over there. But this talk is going to mainly focus on the April 13th evening event, which affected Oahu. So the highest rainfall accumulation with this occurred at Nunu Valley, with a report of 5.52 inches of rain. That's over the course of that 3-hour period from 6 to 9 p.m. that evening. And the recurrence interval of that amount of rain over that period would be 100 to 200 years. That just means there's anywhere from less than a 1% chance of that happening on any given year. So percentage-wise, as far as like the risk goes. There were no deaths or serious injuries reported with this rain event. Okay, so here I'll show you. So what we're looking at here is water vapor imagery. So I got a couple. It's a little hard to see. I gotta put a little circle around the islands there, but where my mouse is where Hawaii's at right there, just to kind of get you familiar with the geography here. So there's Hawaii, and then we have this upper low over here. So water vapor imagery, we're looking at the upper layers of the atmosphere. You got a question?
Yeah. You said, how does that add to the Great New Year's Eve flood about 10 years before that?
Got a whole read up on that, and I'm going to be talking about the New Year's Eve flood later in this presentation.
Okay.
So we're thinking about the same thing here. So it'll be coming up. Okay, so here's Hawaii here, and then we have this water vapor imagery. Water vapor imagery is we're looking at the moisture in the upper layers of the atmosphere. So we're not really seeing the low level, smaller scale features. The oranges and the browns are primarily associated with sinking or drier air masses. And then the areas where you see greens and blues, those are more where most of the moisture is going to be concentrated. So you see a lot of it kind of over the equator there in the tropics. But the main thing to point out here is right here at the beginning of the loop. This is April 13th. And you see this upper trough kind of churning over here. And then we get this moisture over there. And then it kind of reforms back to the west, and that's when Kauai kind of got hit with it. So we're looking at time-wise here. We're looking at UTC time, which is Greenwich, England. So it's about 10 hours ahead of where we're at. So the time when the event was going on Oahu would be between 4 and 7 Z on the 14th. So if you subtract it out, so you can kind of, I can't really stop the animation, but you can kind of see right about that point in the loop where the event was going on. So right about, so let this go. right about there. So, so this is kind of the large scale feature, what was going on. So this is a model data here. This is showing that upper low to the west in plain view. This is actually from April 15th, so this is on Sunday at 2 p.m. But this feature was pretty stationary. It didn't really move a whole lot. It kind of lifted a little bit and then kind of reformed. But generally, it stayed off to the southwest. And what we were getting, so an upper low is a relatively cold pool of air aloft. It means that the atmosphere is unstable right underneath that low and kind of around it. So most of the instability was concentrated to the west of the islands. But what this low was doing was pushing up from the southwest here, following my arrow there, towards the Kauai and Oahu, these little pulses of energy that was enhancing the showers as they came in as they were blown in from the trade winds from the east. So that was kind of the instability that was provided. We had plenty of moisture and lift, and that was kind of the instability there. So the low was centered several hundred miles west of Kauai, and like I said, these little ripples came through across Kauai and Oahu throughout the course of the weekend. So this is the surface analysis. So main thing to point out here is this is a surface trough. So this is kind of a reflection of that low down to the surface. And what we're seeing here is our trade winds are driven by this high pressure over here. And we have faster moving trade winds to the east of the islands, sort of converging right along that trough boundary, because the winds are a little bit lighter right along that trough axis. So we had faster winds sort of colliding with the lighter winds, and that air's got to go somewhere. It goes up. That's kind of where the enhancement was occurring. So we had instability, we had lift from this trough, and so this is April 13th at 8 p.m. So this is right during the peak of the event on Oahu. And then as you see, as we get into Sunday morning, that trough has moved to the west of Kauai there, and the trades are in full swing there with this high to our north, driving our trade winds there. So most of the activity shifted to the west of the islands, but at this point. This is we're looking at total precipitable water. So this would be like if we took all the moisture in the atmosphere from the surface all the way up to the top of the atmosphere and squished it down and condensed it down. How much water would we get out of that? So we use this measurement at the Weather Service just to get an idea of how much moisture is available in the atmosphere. This is not a total, this isn't the only thing we're looking at as far as how much rain we're going to get. It's just like the total potential moisture in the air. So you see these values off to the, on the right or the left-hand side here. These are in inches here. So total precipitable water, 1 inch, 1.2. So you see the color curve there. Now, the April normal is around 1.2, which is about where that blue is. So these values that are over the Hawaiian Islands during this time, you can see them primarily in the yellow to orange range, which is appear near 1.8 inches or so. So abnormally high precipitable waters for this time of year. Now, it's not overall high in general for Hawaii, because we do see these higher levels of precipitable water occurring during the summer and fall months. But that time of year, a little wetter than normal. The main things to point out here is you see this big plume coming in. That's kind of the secondary area of moisture that came in that affected Kauai. But the first one, and again, if we look at on the 14th at around 6Z, so right there, right around this time, that's when this was going on Oahu. And then as we get that secondary band come in, that's when sort of that moisture made it to, that was kind of drier a little bit there, and then we had more moisture kind of come in and go underneath that upper trough, which was up over here, and that upper low again tapped into all that moisture moving in with the trade winds. So the trade winds were pushing this east to west across the islands. So here's the radar loop of the entire event. I'll let you just kind of see that for a minute. So So this radar is the Molokai radar. So it's originating right here. That provides kind of the best coverage for Oahu. And we're looking at the digital hybrid reflectivity. So this is this is all the elevation cuts of the radar sort of merged, and it takes the highest value and puts that, and that's what you're seeing right there. So green, lighter precipitation, yellow, orange, red as you get higher up. So the main thing to point out here is as this stuff starts approaching here, you see right here, this is called a mesoscale convective system. Basically, it means it's an area of thunderstorms which are kind of organized all in one group. They're not going their own individual way. They're kind of in this one little group. And then you see this stuff coming off Molokai. This convective cloud coming off Molokai right there. So this stuff, and then it kind of merges with this MCS, and then it really blows up, and that's when it kind of focuses right there over East Oahu, dumping all that rain over, pretty much from Waimanalo across the Ko'olaus to the, to Nunu Valley and almost to Diamond Head there. But you can see a lot of the other areas around the state. I'm sorry, all the other areas around Oahu really didn't get hit with that much rain. When I show you the rain totals here, I'll get to that here shortly. But let's just talk about the maximum amount of rain that occurred right during that short period. So here's the breakdown. This is this is local time now. So 1930, so 7:30 in the evening is when this got started at Nunu Valley. And then you can see it started peaking right there around between 8 and 8:15 p.m. So the 15-minute peak there is that highest bar there was 1.42 inches. So they had 1.42 inches in 15 minutes. Now at the Weather Service, we like to kind of express when we put out our warnings like inches per hour. That usually gives us when we say 1 inch per hour, 2 inches per hour, that's usually when we're thinking maybe a flood advisory. If we start seeing values on radar 3 inches, 4 inches per hour, that's usually a flash flood warning. But it really depends on where it's falling over and how saturated the grounds are. Falling over urban Honolulu, we're going to be probably a little error on the side of caution when it comes to that, because there's a lot of concrete, there's a lot of structures in close proximity. We're going to be pretty careful with those rain amounts falling over sensitive areas. Now, if it's fallen in the middle of nowhere, we maybe not so much. So if we extrapolate this 15-minute value, we get 5.68 inches per hour. Now, that doesn't mean it fell 5.68 inches fell in an hour. It just means if we extrapolate that 15-minute rate over the course of an hour, essentially taking it times 4, we get that rate, which is pretty high. The total amount of rain that actually fell at the Nunu Valley rain gauge was 5.52 inches. That was between 7 and 9 p.m. So not quite as high rate as the peak, but it's taking into account all these other 15-minute intervals where the rain rates weren't quite as high. Okay, now here's the breakdown by across the island. You can see this is a 24-hour total. 5.5 inches there at Nunu Valley, 4.9, almost 5 inches there on Waimanalo on the other side. But you see when we start moving away from this area, even Aloha Tower 0.24, quite a significant drop off. In fact, most of the island of Oahu really didn't get that much. Now the Ko'olaus, when that first initial pulse kind of came in, a lot of those heavy showers did go anchor along the Ko'olaus briefly, dropping an inch. It's nothing they can't handle up in that area, just because they're used to a lot of rain. But even at Honolulu Airport, only 100. So quite a huge difference. And you can just kind of see that, imagine that with the radar image, all that stuff being focused right over the eastern end of Oahu. It's the Waimanalo stream. So what we're looking at is the river stage here. Obviously pretty flat right up until the event. And then we had a 3-foot rise in 30 minutes. So that's this huge spike here. And then it peaked out at around 5-foot rise within an hour from when the rain started. So that's how quickly the streams can flood around here. It's pretty significant around the rain. Over one area where it's kind of anchored, I mean, we can see pretty significant rises in the streams around here. But the good news is they go down usually pretty quickly because those streams go out to the ocean and they lower rather quickly as well. So the next few slides, I'm going to show you some pictures, and this slide is just showing you where those pictures are from. So the first one is going to be here from Aina Haina, the second one up here near Bellows, third near Bellows, Waimanalo, the fourth one also kind of in that area, although a little further towards the mountains, and then the last one at Nunu Valley. So these are some of the pictures we've accumulated. And then just to show you the scale of the entire island of Oahu, just the fact that it's a pretty small part of the island. So this is Lupe Gulch. This is in Aina Haina. You can see that house nearby. And the main thing to point out here is where I have the arrows. These are showing the high water marks evident along the banks. So where you see these grasses that are kind of brown and kind of blown over from the floodwaters, that marks where the high water mark was at the peak of the flood. So I believe this was a day or two later. This is the second image. Now this is on the Windward Side now. Hawai'i stream, Bellows Air Force Station. This you can see that obviously the floodwaters have receded, but all of this over here, all this debris had been higher up in the along the banks there. In fact, it came all the way up to the road, so likely the road was flooded at one point as well. So for all that debris to be left there, that evident of where that water was during the peak of the flood. This is a tributary of the Kahawai stream. Again, this is near Waimanalo. So this has been temporary rails. Looks like it was installed, but this is a pretty small little stream here. So, but it obviously had overflowed and it washed out any kind of gates or anything that was kind of there, and they put up temporary ones. So this is also from the Windward Side. You can see the road's been cleaned up there, but there's still a lot of debris scattered along the sides of the road there. Considerable amount of runoff at this location during the event due to all the debris deposited. So this is kind of an interesting one here. So this is from Nunu Valley, and this is kind of interesting because you can see how high the water was based on the watermarks there observed on that car and on the fence that I kind of put the arrows there. So you just imagine this whole neighborhood having under that much water. That's the residents indicated there were at least a couple feet of muddy water in their homes, which caused extensive damage. So, and you can kind of see how high it was throughout the neighborhood there. Okay, so we had a question about the New Year's storm. So this I tried to go look for a historic event that maybe compared something similar to this event that occurred in April. Does anybody remember this event other than our one person here? Okay, so this was New Year's Eve, 1987 to 1988. I'm going to talk a little bit about this, but if you guys that are here want to read more about it, I actually have the storm report that I brought with me. So you guys get, if you guys were your historical buffs out there, it's got a whole write-up on this event. But I picked this event because a little different, a little similar situation, but it also somewhat different as well. So what we had was, so this is an old satellite image, 1987. So this has occurred again over the New Year's Eve time frame. So what we had was a stalled front. So we had a low up in this area here, and this front was just kind of stalled. And then you see the Hawaii right there. Like I said, poor satellite image at that time, but you can see the Hawaiian Islands there. But that stalled front and those clouds are sort of anchored over Kauai and Oahu, kind of on the northern end of the state there, from what you can kind of see. What we had was that stalled front, but we also had overrunning trade winds on top of that front. So trade winds blowing from east to west in this area. So you can just imagine this long fetch of clouds being carried by the trade winds and just sort of piling on to the Kauai and Oahu. So we also had moisture from the front. We had the trade winds kind of providing the lift, the mountains. And then we also had a digging upper trough not associated with this front that brought clouds in from the southwest, which superpositioned over the trade wind shower. So we kind of had a similar situation where we had an upper level system to the west of the islands, and that southwesterly flow kind of brought in this deeper moisture over the western end of the state. And then combined with the trade winds carrying that old frontal moisture over the same areas, it just kind of blew up right over Oahu, East Oahu. And essentially this continuous heavy rain from 9 p.m. to 3 a.m. over the New Year's holiday. Here is the rainfall distribution from that event, and those are inches. So that's 20 inches of rain right there over the Kolaus. Pretty concentrated right over the eastern end of Oahu. And then as we get, 5 inches, 1 inch, a lot of the island didn't really get a whole lot, but it was just this really small area of very heavy rain. The 20 inches, however, that was more than that fell during this April event. However, if you look at the time distribution of that, so again, these are in inches, you see that it was actually from around 8 p.m. all the way to maybe 2 in the morning. So it was the event lasted, quite a bit longer, 6-8 hours in that time frame versus the Oahu event, which was only around 2 hours. Most of the rain fell. So it makes a difference how much rain fell, but also in what time frame that occurred. But you can see all the way up to rain rates of about 3.5, almost 4, getting close to 4 inches an hour. At the peak there, but then 3, 2. So obviously, as more rain's falling, the ground's getting more saturated. Eventually, it's going to lead to flooding. But this one was just a little more spread out versus the April event. Okay, so that's kind of the comparison with that event. For future flood potential, when can this happen? This happened before in 1988. It happened this year. What's the chance of it happening again? Well, upper lows or troughs can regularly move by or skirt by the islands during the winter wet season. So we typically, our wet season here runs typically from November to March. Usually we'll see kind of a transition right in that November time frame. Sometimes it'll let off a little bit, maybe December, January, and then it seems to kind of fire back February and March. But generally that's going to be our time frame where we get these winter time upper lows or upper troughs digging from the mid latitudes down near the islands. Usually in the summer it just doesn't happen. It's just not. We're usually dominated by the subtropical high, and they just can't get this far south in the summertime. So these are a regular occurrence is basically what I'm saying. A precipitable water of 1.8 inches is high, but we do get higher. We do see values 1.9, 2 inches, 2.1. With tropical cyclones, sometimes we could even see higher values. So it's not the only indicator of potential for heavy rain. If we see an unstable setup with high PWs like that, then we're getting a little more concerned. We're probably putting out a flood watch, and we're monitoring for flood advisories and warnings at that point. But just having 1.8 inches of precipitable water doesn't do it on its own. Here's a big point I want to drive home is this third one. We see storms on radar range dropping instantaneous rainfalls of 4 inches per hour several times each year. But oftentimes it's over the ocean or over an unpopulated area where no one notices. Our radar range extends out couple hundred miles from the islands themselves. So we'll see these intense thunderstorms and heavy rain, heavy showers over the water. It's not really hurting anyone, but it's just a matter of time where it's just going to hit. It's going to hit one of the islands, and it's going to and it's just going to drop a lot of rain in a short period of time. So this can happen at any point. East Oahu got unlucky this year with that, and they did in 1988 as well. So there's a small chance of it happening in any given year, but obviously the impact is great. Urban areas in general are more prone to flood damage. I kind of touched on this earlier, just because you have a lot of concrete. There's not a lot of place for the water to go. It just kind of flows down the streets, and you also have many structures packed close together. If it's out in the country, out in the farm, where everything's kind of spread out, you're not going to get as much flood damage as you would where in the city, where you just have a lot of houses and a lot of structures very close together. Where can you get information from us? So at the time, we had a flash flood warning out, which that should alert on your phone with the wireless emergency alert system. As you can see, this list there's only 8 things. There's not that many. So don't rely on your phone to tell you if there's potential weather coming or if there's any kind of hazards out there. This is just, we don't want to be sending these out all the time. We just want to make sure if we're sending these out that you're in the immediate danger area, and it's depending on where your position is relative to the cell phone tower. So these messages will come out if you just happen to be in an area or in our flash flood warning box that we've drawn, or when any of these other hazards are issued. If you want a more extensive way to get our weather products, HNL Info is an app you can download. That's by the City and County of Honolulu, and so you can customize your messages. You can put other things like fire messages and board of water supply and transportation and that type of stuff. But there's also one for weather, so you can put all of the weather products on there. We also stress that everyone has a weather radio in the event that the power goes out, your cell phone doesn't work. This will be kind of the last resort. You don't have to listen to it every day, but you may just want to have it somewhere where if you need it, you can have access to it. That's going to broadcast all of our weather messages with an automated voice. So that's going to be automatic and up to the date of when we send those out. We're also on Facebook and Twitter, but if we get really busy, I wouldn't count on us having that information 100% current. If you want 100% current, though, I always stress, go to our website, weather.gov/Hawaii. That's going to have all of our products, and that's going to be automatically updated as we send them out. The local media, of course, you can turn to them. They're going to be relaying the messages from us as well. And mahalo for your attention. Yes. Thank you. You had a question, yes.
Yeah, kind of related. Does the Weather Service track soil saturation? Was the 80-78 meters that one that overtopped the dam in Hawai'i Marsh and flooded all the houses and tried to go inside by the canal?
I'm not sure on that one.
Sure.
I'd have to. It'll be in here I've read through part of it, but I'm not 100% sure on that.
Over there at 5 feet of water.
Oh wow!
Canal.
Yeah.
Last one. I'm listening to see that April predictable.
Why wasn't it predictable?
Yeah, predictable in the sense of some advanced notice rather than.
Well, I mean, we knew that there was potential for. I didn't go back to look if we had a flood watch out at that time. So I'm not 100% sure. We of course do our best, and if we put out a flood watch, we're really wanting people to be aware that there's a potential for something like that to happen. And
There's just something unique about what happened that is so instantaneous, it cannot be seen by all the happens.
it's it's really hard, and yeah, you can see how fast it just came up on that area. A lot of times when we see these heavy showers or thunderstorms approaching like that, I mean, we're just kind of we're ready to react to tell people that it's coming. But a lot of times with the mountains, interacting with it, they play a big role in determining where the precip falls, and it just happened to kind of converge right in that area, and we had a warning out, but that's kind of the best we can do at that point.
Sorry, we do have another speaker, and then we're going to take questions after that. If you can please save your questions.
Okay.
For the very end of this talk. I forgot to make that announcement earlier. Okay.
Praying is enough.
Okay.
Okay. Thank you. And if anyone wants to read this.
And maybe some of your questions will be answered by
Maybe.
Maybe.
I see. I'm Brian Loving. I'm a hydrologist with the U.S. Geological Survey's Pacific Islands Water Science Center here on Oahu. And I'll start by I'm going to talk about the floods, just similar to what Matthew did, and kind of this focusing more on the streams than on the rainfall. But I'll quickly go through just kind of what USGS does. Not everybody is familiar with this. We're not as well known as, say, the National Weather Service. So this is what comes off of our agency's website, but basically we are the primary natural science agency for the federal government. So we're a federal agency, and we monitor earthquakes, volcanoes, minerals, water, also biologic resources. We'll do a lot of research and science and collect a lot of data for other agencies that do, say, we'll collect data about the streams, but then the National Weather Service will report that there's a flood warning or things like that. Or we'll do studies on wildlife, but then the U.S. Fish and Wildlife Service will do the managing and do the enforcement of the Endangered Species Act and things like that. So that's who USGS is as an agency. Our office here, the Pacific Islands Water Science Center, is about 40 scientists and staff based on in the Inouye Regional Center for NOAA at Ford Island and Pearl Harbor. We have two main sections in our group. The section I'm in charge of, we monitor hydrologic conditions across the state of Hawaii and then also other U.S. affiliated islands, Pacific, including Guam. And that includes monitoring the stream flow, certain water quality parameters, the groundwater level and the aquifers. We also measure rainfall at, in Hawaii, about 20 sites. And then on Guam, we have another 7 locations where we monitor precipitation. So we also conduct studies. So we always have research studies and modeling going on in our office. So we have probably about 15 scientists that are working on around 25 active projects that deal with groundwater availability, surface water quantity and quality, and then also water quality issues related to land use. So, and then again, most of our funding actually doesn't come from the U.S. government. It comes from state and local governments. City and county funds us to do work, and state of Hawaii funds us to do work to collect these data and also to do the studies. So I have one more slide with any pictures on it before we move into the good stuff. And I just want to quickly go over a couple of definitions so that you're clear about things I'll be talking about as we go through this. The first is flood recurrence interval, and just kind of a definition of that is the percent chance that a flood of a given size will occur in any given year at a site. And this is often expressed as a number of years. So Matthew talked about some of this with rainfall. So an example for us would be that there is a 50% chance that the flow at our Lupe Gulch gauge, which and Matthew had a picture of that site, will exceed 552 cubic feet per second, which is the unit that we use to measure the flow of water, at some point during each year, which makes it likely to happen once every 2 years. And so we call this a 2-year flood or 2-year recurrence interval. And then the other definition I talk about is stream stage, because this gets confusing sometimes to people. The National Weather Service might report they know that this stream has exceeded the flood stage of 10 feet. That doesn't necessarily mean the stream is 10 feet deep. We pick some arbitrary elevation that has nothing to do with, it's confusing to the public, but we just go out there and we say, all right, we're going to go below the stream a little bit and say, all right, this is going to be 0. And so we want when the stream's dry or is going dry, it's going to read 2 or 3 feet a stage normally. And then when it goes up, it gives you some indication what the depth may be, but it's not exactly the depth. In fact, we have some sites here that are tied to sea level. So we'll talk about like the Lupe Gulch site or Coolio. We might report that this stage is 35 feet, but it's not 35 feet deep. It may only be 3 feet deep. It's just 35 feet above sea level. So I want to make that distinction because it can be confusing to people. But I'll kind of talk about that as we go through the slides. So our network, this is our network of stations that we have here on Oahu. We have sites across the United States that the agency operates. It's a little bit difficult to see, but you can kind of see these colored dots that stretch across the island. The grayish dots are, here's some example over here. Those are our stream and reservoir monitoring stations where we're measuring the water level in streams and reservoirs. The red dots are groundwater wells where we monitor the aquifers, and then the blue dots, there are 4 or 5 on Oahu, are stations where we measure precipitation. And by and large, our precipitation monitoring that USGS does is up on top of the mountains. And the stuff that's down in town, like Nunu Valley, is usually monitored by other agencies, but we have, ours are generally up on top of the mountains around the state. So anyhow, all of our data are available at that website up there. And most of these stations, nearly all of these stations on Oahu are available, the data are available in real time. It transmits once an hour and then gets updated to the web page for these different parameters. Okay, so I'll show you a couple of pictures of the stations where we monitor, or to show you how we monitor the stream stage. So this first type is going to be what I call a continuous stream gauge. So this example is from Manoa Stream at Woodlawn Drive in the shopping center's parking lot, basically. So the stream comes in on the Mauka side of the parking lot, and it's just this little building here that has some electronics in it. We have a sensor like this one in the middle of the slide here. It's a pressure sensor, and it's down in the water, and there's a wire that runs down from the box down to that sensor in the water. And so as the water comes up, it increases the pressure on that sensor, and it gives us a reading where we can monitor the stage. You can see that in this graph here. This is a measurement from last week. This is all week what the stage was and how high the water was in Manoa Stream at Woodlawn Drive. So these data, again, it measures every 5 minutes, and then the data are transmitted every hour. And when it's flooding, it actually transmits more frequently than every hour. So that's kind of our fancy gauge. We have a very simple gauge that we have installed at other locations around the state. All they measure is how high the peak of a flood was. And it's a very simple thing where we just have this metal pipe. If I can get my cursor on it, we have this metal pipe, and you can see this technician down here, he's on one in Coolio. And inside that metal pipe is a stick. And on that stick, we put the stick down in the pipe. We have this is actually kind of like sawdust that's made out of cork that just sits in the bottom of the pipe. When the stream comes up, it floats that cork, and it goes up to the high water mark as high as the stream gets. As the stream starts to recede, cork sticks to wherever that high water line was. So we can just pull the stick out and measure that up, and we know how high the stream got. So it's a cheap way for us to measure just the peak stream flow at a site instead of a continuous record. And so we use this, I would say 2/3 of our gauges around Hawaii are this type of gauge versus the other kind.
So that's not in real time.
This is not real time. No, it just measures the highest level that the stream got between visits. So we'll go usually every 8 weeks, and then we keep track of how high it got each week and what the product that we derive from this normally. I mean, it gives us information for specific flood events like the one we're talking about now. But also, we're really interested in what was the highest peak of the year, because that's how we figure out what that 100-year flood is you only really need to know the peak of the year. So you don't have to have a continuous record to come up with those 100-year flood values. So that's what we're doing here. So we've had this gauge on Coolio Valley since 1970, and you can see all of the peaks we've measured. Here they're shown in the flow rate, the cubic feet per second instead of stage, but sorry. Anyhow, so those are the 2 types of gauges that we have. So here is that map that Matthew showed us I got it from his office. And so it's just that base rainfall map of all the rain gauges across the state. And I took and crudely colored in here with the blue line and the red line. Hopefully you can see that okay. Kind of an estimated area looking at those of which areas in blue there had rainfalls between 4 inches and 5 inches. And then the area in red would be greater than 5 inches. And I know that's not exactly right. That's just an estimate. It's definitely off in some places. But I wanted you to I wanted to show you where our gauges are in that part of the island with respect to where my estimates are of where the highest rainfall amounts were. And so first I'm going to show you our continuous gauges. Oh, yes, go ahead.
The continuous gauges, that's available online, can you dial them up?
It is.
Like the-
It is, yeah. And I'll go back, when I get done, I'll go back and show you what that website is again so you guys can write that down or take a picture of it. But it is available all the time on the web. So these three sites, or these three green stars, are sites where we do have that continuous record. And then these 5 red stars are areas where we have the cork and stick type crest stage gauges. So I'm going to go through each of these stars individually and show you what we found, what data we collected during this flood. So I'm going to start off with kind of at the far western edge of the area here with Pookal Stream. On the April 13th flood, we had a peak that was 4.32 feet of stage. And so that worked out to be about a depth of 3.6 feet at that site. And you convert that stage to flow rate, which I won't get into how we do that, but we measure the stage of the stream, and then we have several different ways of converting that into an actual flow rate of water that's moving down the stream. That equals out to 479 cubic feet per second, which is about a 2-year flood. So further out to the west, the rainfall wasn't as intense and the totals weren't as high. And so it was about a 2-year flood out there. Just for reference, the historic peak at this site, when we have 66 years of record, was back in 1930. It's not a continuous record, so there were gaps in that record, but the gauge was in operation back in 1930, and that's the highest peak we ever measured, which was 2,600 CFS. And again, yeah, you can see in this top right, this is the graph of the data from that. I think is actually from basically just that weekend, the 12th through the 15th, and you can see the peak on there right around 479 CFS. All right, so then moving east, the next gauge we have is on Lupe Gulch. So this is in Aina Haina. The April 13th peak was at a stage of 18.80 feet, and that's a depth, that's a deeper depth. That one was about 9 feet deep. And that converted to a flow of about 2,720 CFS, which is more of a 25 to 50-year flood. The record peak at this site was back in 1967, and it was 3,600 CFS. And that was at a site that was about a half mile upstream that we discontinued it, I think, yeah, it says up there, and we discontinued that site in 2009. Our gauges are based on funding. If we lose funding, then the gauges go away. So this gauge evidently lost funding for a while, but it came back online 3 years ago on the East Honolulu Road Bridge. So that's where it's located now. And you can see up here, this graph is from the old location, though. That's the historic record of peaks at that site. So you can see that 2,720 CFS would be somewhere up here. It's the second highest peak in our period of record on that stream. So here's a photo of that. The photo on the right is pretty much, it's a photo that we took, but it's very similar to the one that Matthew showed you of that stream. And you can see, for reference on the left, that's what it looked like about 6 months before the flood when we were there. It was just completely overgrown with vegetation. And this flood blew all that vegetation out. And I mean, you can actually see, it's hard to see with the colors up here right now, but you can see the ocean now in the far end of that stream, which you couldn't before because of all the vegetation. So you can kind of make out the high water marks. This is 2 days after the flood. You can kind of see basically where it's green. The water got up into the green a little bit, but down here it was deep enough and fast enough that it just washed all that vegetation off.
This isn't channelized, is it?
It's, I don't know. I think it probably is. It'd be highly, yeah, it's not, it is channelized, I guess I would say. It's not channelized with concrete like a lot of the streams are in this part of the island, but it does have riprap or boulders that have been placed in it. Yeah, streams are never that straight. So.
I believe it's channelized. If you go to the Pampa side of the East Side Bridge, then that's actually, it is uncemented.
Okay, moving on east to Coolio. Our gauge on, you can see Coolio is just right. Coolio Basin was hit based on my red lines, which are probably not right given the amount of rainfall density, gauge density we have in this area. Looking at that red, though, it would be in one of the areas with the most intense rainfall in its basin. That basin comes up into this, basically is mostly falls within that pink area there. So Coolio was obviously hit hard. Our gauge, just for reference, so here's the highway down here, and Coolio stream comes down the right side, what looks like the right side of the valley here, and then makes its way down. And our gauge is clear up here near the top, not the very top of the valley, but there are apartments or condos right in. I cannot see your cursor. There we go. I should use the mouse instead of my finger. There we go. But anyway, our gauge is up here at the top. So I want you to keep that in mind. So some of you that live in this area, you saw the effects of the flood down the road. And where we're monitoring up is up higher at the top of the valley. So we're going to catch all the rain that fell up above the housing parts in the developed part of the valley. But we are not catching everything that fell like on this slope of the mountain here, or stuff that fell directly in the valley in the neighborhoods downstream of our gauge. So our peak there, I have it as, I don't have a good way to show this. We have those pipes with the sticks in them. We have 3 sets of those there going down the stream up by that gray symbol. And the center set of pipes, the ones we usually key, that's the one we use for our record peaks and to record what things are off of. That one got plugged up and messed up during this flood. The middle set did, but the upper and lower ones worked fine. So what we did to, just as an estimate of stage, the water surface we think was straight. I mean, it was going downhill through that reach, but there wasn't, it was a continuous line. So we just basically interpolated between our upstream and downstream pipes and came up with a stage of 28.95 feet, which kind of matched up with the little mud lines and stuff that we saw on the channel at our center set of pipes. And that gave us a stage of 28.95 feet, which is a depth up there of about 3.5 feet. So again, for reference, and I'll show you, let me go up and pull. So here's a picture of the channel at the gauge. All right, so this, from the bottom of the channel to the top where it overflows, is about 8 feet, maybe a little over 8 feet. So it wasn't even quite half full up at this point. It was going through there really fast, but it was only about half full, maybe a little bit less, up at that stretch, that high up in the valley. So the discharge that we computed from that, we were able to compute a discharge using the upper and lower set of pipes with our model that we run. And we got a discharge of 1,700 CFS, which is a 10 to 25 year flood. The record was the New Year's Eve flood back in 1987 and 88, and it had almost 3 times as much water. I don't know what the depth was, because at that time the gauge was in a different spot further downstream, so we can't compare how deep it was at that time because they're in different spots. But the flow rate was, there was 3 times as much volume of water coming down in that New Year's Eve flood. And our historic record here is 45. We have 45 years of record at this site. Okay, so the next site is way out at the far eastern point of the island near the Hawai'i Golf Course. This is the Kalama Valley Drainage Canal. It had a peak stage of 14.28 feet, which is a depth of about 3.3 feet. And so this one also is about, see, it's 19, the top of the channel is 19.5 feet of stage. And we were down, the bottom is at around 11 feet. So it's also about 8.5 feet deep, the channel is, and looks similar to what Coolio does. So it was also not quite half full. This one, we were not able to compute the discharge, the flow rate, because we run a model to compute the flows in these based on the water elevations on our sticks and the shape of the channel. And the channel needs to be a clear, open concrete channel. And this one happened to have a bunch of trees growing in it. You can actually see on the satellite photo, they were in there at the time. And so that messed up the readings. So the stages were good, but the model looked at those stages and it said it didn't make sense because the model expects the channel to be open and it wasn't. So we don't know what the flow rate was at this site. And this site's a new site. We've only had it in it's now been in for about 2 years. Here's what that channel looks like. So again, it's right by, there's the parking lot for the Hawai'i Golf Course. So it's just on the, I guess what would be the south side of that parking lot. And you can see our pipes that monitor down the side. There's one on the other side. You can see where that vegetation, there's still some of it down there. This is a couple days after the flood. It blew a lot of that vegetation out, but there's still some down there. And you can see that this whole channel should look like it is up here, but it's kind of, water's dammed up down here from that mud and the trees and stuff, the vegetation that's down below. All right, moving around over to the Windward Side. Hawai'i stream is our next stream that we have. So this site had a peak stage of 14.66 feet, which is about 6 feet deep. It also, we were unable to compute what the discharge was there. In this case, we had backwater either from, it goes down and hits the highway just around this corner to the left. It could have been debris jammed up on that bridge backing things up, but there also Waimanalo stream comes in to the left just down there too. And Waimanalo stream was running high enough, it could have backed up water to this point. So we may need to relocate this gauge further upstream to get out of the backwater from Waimanalo stream. We're not sure yet if that's where it was or not that caused that backwater, but the record peak flow here in our 19 years of record was 2 years ago. We had 517 CFS, and that was during tropical storm or Hurricane Darby. It was a tropical storm at the time, Darby, when it came by.
Right then by the time.
Okay. All right.
Was tropical storm.
Okay. Going on to the next gauge we have. So this is another continuous gauge, Waimanalo stream. The peak there was at 12.34 feet of stage, which is about 5.5 feet deep. This is one that Matthew showed in his presentation. That equaled about just over 1,000 CFS, which is a little less than a 2-year flood. So this is really the smallest peak, given the drainage basin size of this stream. This was actually the smallest peak of the group, which tells me that my pink line is probably not drawn quite right. And also the mountain ridge with the boat allows, so go back, let me use this. Don't jump ahead. It kind of comes up here to where there just may not have been as much rain actually in that Waimanalo stream basin. Now we have 50 years of record there, and the peak at that site was back in 1963, and that was 4,560 CFS. And this is a picture of the channel, just kind of upstream from the highway. There was enough water to push this car down. That car was not there. We're pretty sure that wasn't there. It wasn't there a few weeks before the flood, but that was there right after the flood for a couple of days until it was removed. All right, this is a small stream, Kaelepulu, and it is on up past, closer into town, I guess, in Waimanalo, up past Waimanalo. It's a very small stream. It had a peak stage of 6.26 feet, which is about 6 feet deep, and which is a lot of water there. So that was 332 CFS, which is about a 5 to 10 year flood. The record peak there was actually only a few years ago, whatever that is, about 12 years ago, and that was 488 CFS. So this was, I can't remember, I think this may have been our second highest peak in the 54 years of record we have there. And then the last stream I have is Makawao stream, which is on past Waimanalo, probably closer to up above Kailua. It had a peak stage of 14.55 feet, and that's about 10.5 feet deep, which turns out to be 3,500 CFS. That's about a 10 to 25 year flood as well. Record peak there was back in 1965 with 6,000 CFS in our 58 year period of record. Here, so this is a continuous gauge. You see how fast that thing came up, those 10 feet or so. And right before it hit the peak, it ripped out our sensor there. So the red little dot up there is our high water mark that we entered in for that site. And you see the blue line goes almost all the way up to that, because right at the last 10 minutes before the peak, 10 to 15 minutes, this entire bank, so our sensor, this is our pipe. Our sensor is in a metal pipe, extends around and comes down here, and here's actually the end of the sensor. This was all buried in the ground, way out off the screen, and the bank eroded out so much, it exposed all of that and just whipped the whole thing over. And we've seen that actually on Oahu. That's the only place that's happened to us this year, but I would say in the last 2 years on West Maui, it's happened to us in like 4 or 5 places. It's gotten torn up a lot, and Kauai, North and East Kauai have had the same thing happen too. It's really been a lot of serious floods that have caused a lot of bank erosion. We've lost on both sides. It would wash out a lot of the banks. Kauai was hit. Yeah, Kauai was probably hit worse during, as far as damage and stuff. I don't know, damage was bad here too. There's just a lot more people here, but the flooding magnitudes on Kauai from the same storm as it moved on west of here was pretty bad. So that's kind of the last thing I would say. We put together a report in the 2 weeks after the flood that kind of talked about most of the stuff that I've just shown you here. And that's on our webpage, which this is the same webpage where you can get the data from our real-time data and the graphs. And we put together another sheet like this for the Kauai floods that happened that same weekend. So if anybody's interested in that, you can check that out there. That's all I have. Should we go ahead and open up? Can we do questions while I'm already up here? Okay. Yes.
Question. Can you comment a little bit about trying to put all this into perspective? You have a mountainous area, say 700-800 feet high, 5 inches of water hits the top and the bottom. The cumulative effect, what hits the highway and wipes out all cars. Is that what you're talking about? That see the water?
With so we have like
a wall of water knocking everything off. Right?
the time. It's the time how it comes down. So the time and where that rainfall falls. So normally here the rainfall is greatest at the higher elevations, but when the storms come through like that, different things can happen. Like in Kauai, Honolulu, and that when that event went through Honolulu, the storms dumped much more water down in town than they did up in the mountains. And there were a lot of landslides we could see down in town, and we didn't see landslides when we went way up in the valleys. So some of it's the timing of when it happens, but it's also where that rainfall comes and what type of surface it hits too. So up in the valley, way up in the valley, it might absorb more of the water, but down, when you get in the neighborhoods like that,
You got a lot of
yeah, you look at Coolio, all the houses and stuff. Get back to that somewhere here. Slow to go back, but yeah. So there's a lot of that goes in play, and what causes for how high the peak reaches depends on where the rainfall falls, how much water can soak into the ground, and how steep it is, how fast it can get down there to get out.
hard to understand. Cars were wiped out on the highway.
Right. Yeah, and I'm not sure. Again, I'm not sure, and I wasn't there at the time, and I didn't even go up there that next weekend to see the damage that was done. But I'm sure that a lot of the water that ended up crossing the highway didn't come down the stream. It would have come. A lot of water that fell on this slope over here on the west slope, that fell on the houses. The storm drains were probably overwhelmed. It was just running down the streets. Yes, question in the back.
This may be a question for the first speaker. 2 times I heard him talk about the fact that there's too much concrete. The city gives the permits for people to completely pave concrete for parking 4 cars in their front yard. They need to be told to say no. You can't have a front yard of cement. There has to be some grass somewhere for the water to go. We are paving over our lots. There's a house sitting in a pond of cement. We're doing it to ourselves.
Yeah. Yes.
I have 2 questions. First is a simple one. How often do your vehicles get vandalized? And the second one is how often do you send reminders to our government to check the culverts? It's supposed to be doing.
No, those are both good questions. So first, how often are gauges vandalized? Actually, I've been in Hawaii for 2 years, and I came from the mainland. And the mainland gauges all over the mainland get vandalized all the time. Here, I don't know that we've had a gauge vandalized. We had stuff stolen from gauges on a weekly basis. It's theft because there are batteries in there. Don't tell anybody. It's on YouTube Live, and everybody knows there are batteries in there, and there are solar panels. And a lot of people want batteries and solar panels. But I will say too that the people who steal things here are generally pretty nice. There's aloha in their thefts because they don't take any of the expensive stuff. They just want the stuff they need, and the stuff they don't need they leave alone. So we appreciate that, but it does happen fairly often. As far as the
same result.
we still have to go back. Yeah, same result as far as that, but it's good for us because if somebody takes everything, it costs a lot of money, and it gives them something that they have nothing. They can't use it anyhow. But if they just take batteries, we can replace those. The culverts, it's something we have to talk to the city and county frequently, saying, hey, because we need the culverts cleaned out too, just to collect good data, and community needs the culverts cleaned out so that the streams don't back up and flood areas.
The culverts now, the existing configuration, good enough to protect the place? Should there be more?
That I don't know, and it's going to be site specific. Yeah, that I don't know. Yes.
How can your gauges tell if it's the water flushing down versus back?
As far as the water summation stream,
What you're measuring.
that is, for those crest stage gauge pipes, it is a challenge. And I think that's part of the problem that we had at Coolio is there is right here on our middle pipes, there's kind of a road that comes through that way. And our pipe is at the end. It's not a road. It's the end of a parking lot in that apartment complex. But I think the water was so high that it may have been just pouring over the sides, and that flushed all the cork that was measured in there just down at the bottom. So the readings were bad in that. Normally in a stream, though, it has to fill with the regular pressure gauges at the continuous gauge. It has to fill up the entire area. So it's got to be all that. It can't just be water pouring over. It has to actually fill something up and be coming up for it to know, for it to measure that water.